In this lesson, we'll be looking at what are called similar figures, and we'll be solving for the missing side lengths of similar figures using our knowledge of proportions. So in order to find the missing side lengths of similar figures, let's start by actually defining what a similar figure is. So similar figures are two figures that have the same shape, but not necessarily the same size. So essentially, this is just a smaller version of this bigger triangle. And they are what is called proportional. So essentially, it looks like I just took this small triangle here and made it 2 or 3 times bigger to create this same triangle here. They're proportional. Now, when we have these triangles, we can write what's called a similarity statement. And the similarity statement matches up those similar or proportional angles that kind of match up together. So what I notice here is that this triangle, say I were to trace it A, B, C, so in that way, so A, B, C, and end there. If I were to trace this second triangle in the same way and kind of put the corresponding angles together, it would be D, F, E. That's how those angles would correspond. So my first angle would be A and D, my second angle would be B and F, and my third angle would be C and E. So our similarity statement is going to put those angles in order and basically match up the corresponding angles as we name that triangle. So here I'm going to put triangle and triangle to signify the shape in my similarity statement. Then I'm going to put the first angle first, so A and D, then B and F, and C and E. So what we have here is we're naming these triangles in a corresponding way. We're naming them with the angles in that corresponding direction so that we could say, well, angle A matches with angle D, and angle B matches with angle F, and angle C matches with angle E. Then from here we put what's called a similarity symbol in between, which is just this little tilde. If you've taken Spanish class, you've probably seen these before. And here we have our similarity statement, stating that these two shapes are proportional versions of the same triangle. Now, what's really cool about the similarity statement is if we have a similarity statement for a set of triangles, we can actually identify all of their corresponding parts. And in a triangle, we can have corresponding angles. So these are the angles that go together, which I think will be the easy part. So we have corresponding angles, and we kind of discussed this on the previous page. So basically we can match up angle A and say that that one matches up with angle D. So we kind of talked about that. We can then say angle B corresponds or matches up with angle F. And angle C corresponds and matches up with angle E. And remember, we write our similarity statement in this way, so we have the first angles together first, written first, the second angles written second, and the third angles written third. So that way we can see exactly which angles all match up. So the first thing we can identify are those corresponding angles. Now beyond this, we can actually use our similarity statement to match up corresponding side lengths. And a side length will basically consist of connecting two angles together. So what I notice here first is that my first two letters in each triangle name are AB, which is right here, and DF, which is right here. So what's cool about this similarity statement is not only does it tell me about the corresponding angles, but it also tells me about the corresponding side lengths. So here what I can do is I can say, well, because AB, so I'm going to put AB and then put a little line above it to say it's a side length, and DF, because those are the first two letters, those are corresponding sides that are going to be similar sides. If I then look at the next two letters, which are B and C and F and E, B and C, F and E, again, I have two side lengths that are corresponding. And then if I look at that third set, so it's kind of going to be these outside letters of C, A, and E, D. C, A, and E, D, or you can call them A, C, and D, E, it doesn't matter. Those are also corresponding side lengths based on that similarity statement. So just by having this statement here, I can find a list of corresponding angles and a list of corresponding sides. So where the similarity statement really comes in handy is in pictures like this, where the triangles are turned around. Maybe it's not super easy to see which side lengths match up with which angles. And so here our similarity statement is really going to help us as we find all of our corresponding angles and all of our corresponding sides. So I'm going to start here by finding all of my corresponding angles, and I'm going to use my similarity statement to do that. So if I look at the triangle names in my similarity statement, what I notice is that L and P come first. So what that's telling me is angle L corresponds with angle P. That's what that similarity statement is telling me. Then I look at the second angles and I see M and Q. So then I know that angle M matches angle Q. Those are corresponding angles. Then here I can see lastly that angle N corresponds with angle R. So then if I kind of go through and trace that shape in order, it would be L, M, N, and then back. And it looks the same now when I trace P, Q, R, and back. So those similarity statements are really nice when all of those shapes are just kind of turned around and you can't clearly see, or you can't know for sure exactly which side lengths and which angles correspond. So now we're going to do the same thing with the side lengths. We're going to find those corresponding side lengths using the similarity statement as well. So here I have L and M and P and Q. So L and M correspond with P and Q, which to me, if I look at those triangles, makes sense. I then can see from my statement that M and N and Q and R would be corresponding, which again, from my picture, seems to make sense. And then lastly, if I look at that last pair, it would be N and L, so right here, correspond with R and P, which again, based on my picture, seems to make sense. So I can identify all of those corresponding angles and all of those corresponding sides by utilizing this similarity statement here. So now that we know what corresponding angles and sides are, I want to talk about what we know about corresponding angles and know about corresponding sides. So here, angles we're not going to talk about too in-depthly, but if you notice here, we have corresponding angles of A, B, C pairing up with D, E, F. And while I don't know the measures of all of these angles, what I can see is angle B and angle E are right angles. They're both right angles, they both have the same measure. So what that part of this picture is telling you is that corresponding angles actually have the exact same measure. So within this picture here, these corresponding angles, so you're going to have angle A is equal to angle D, angle B is equal to angle E, and angle C is equal to angle F. So that's the first really cool thing you can pull out of here, is you can actually state that those corresponding angles have the exact same measure value. Now, the other thing we can do is look at a pattern between the side lengths. And hopefully you're noticing, okay, AB pairs with DE according to my similarity statement. And, then I have BC pairs with EF in my similarity statement, and AC pairs with DF. And what you're probably noticing here is that every single side length over here in this little triangle, if you multiply every side length by 3, it becomes its side length in the bigger triangle. So we can see that they're proportional. The sides in this triangle are 3 times bigger than the sides in the other triangle. So we can clearly see we're multiplying every side length in the small one by 3 to be the big one. What you can also see here is if we create fractions out of our corresponding side lengths by putting the smaller triangle in the numerator and the bigger triangle in the denominator. So if we start with the red side, that would be 2 over 6. Notice numerator over denominator, small triangle over big triangle. If we then take the next side length, 3/9, and the next one is 4/12. What you should hopefully be noticing is all of these, if you simplify them all down to their simplest form, so we would divide these by 2, these by 3, and these by 4, they all become 1/3. So these side lengths here all represent the exact same ratio, which means we can create proportions out of these side lengths in the future to help us find missing sides. And that will make more sense as we look at the next few shapes. So now we're going to use all of this knowledge to help us find the missing side length in this particular set of shapes. So here we can see we have two similar shapes. And since we're focusing on side lengths here, I'm going to go ahead and color code all of my side lengths here for my similar triangle. So here, what I want you to do is get some colored pencils or get some different colored pens, and what we're going to do is we're going to color code all of these side lengths so that we can see which side lengths actually match up together. So the first two side lengths I can see that match are T and I and G and O. So those I'm going to put in green. Then if I pick a different color, I and S and O and D. And then my third color is going to be S and T and D and G. So what this does for me is, as a visual learner, it really makes those corresponding side lengths pop. Really makes them just pop out at me. So now what I'm going to do is I'm going to create 3, or only 2 if I don't have all the side lengths, different ratios of those corresponding side lengths. And what I'm going to do is I'm going to call this right here triangle 1. I'm going to call this triangle 2. And I'm going to make ratios out of its side lengths by putting triangle 1 over triangle 2. So I'm going to start here and notice, okay, I'm going to start with the red side lengths here. So I'm going to put triangle 1 over triangle 2. And then I'm going to focus on the green side lengths. Well, I don't have any measures there, so I can't create a ratio. So then I'm going to move on to the purple side lengths, and I can see X and 16. So I have X is triangle 1 over 16, which is triangle 2. Now on the previous slide, we learned that these two ratios, when simplified to their simplest form, are exactly the same. And remember, the definition of a proportion is two ratios that are set equal to each other. And what we can do here is we can take these two ratios and say, well, I'm missing a piece of these ratios, so I'm going to set them equal to each other. I know that in their simplest form, these two fractions simplify down to the exact same simplest fraction. So they have to be equal in their simplest form. So notice I created two ratios by doing triangle 1 corresponding with its side length over triangle 2. I've now created a proportion, and then I can utilize cross multiplication to help me solve this. So I have 20 times 16 is equal to 12 times X. 20 times 16 becomes 320, and then that's 12x. Divide both sides by 12, and I end up with x is equal to 26.67-ish about. And what that's telling me is that these two fractions, so we have 20 over 12, and then we have 26.67 divided by 16. If I take these two fractions and divide both of them, 20 divided by 12 is 1.67, and 26.67 divided by 16, that's a 16, not a 10, 1.67. So these become the exact same value. So this is just kind of work to help us check that our answer was correct. But if we use our knowledge of ratios and proportions, we can actually find that this missing side length right here, if these are similar triangles, would be 26.67. So here we have a new set of triangles. So let's start going through that same process here. We want to find the missing side lengths. We're going to focus on those corresponding sides. If I use my similarity statement, I can see A and B correspond with M and N. So I'm color coding those different corresponding side lengths. I can then see B and C and N and L. So B and C, N and L. And then my last set of side lengths, which is A and C and M and L. So I can see my three different sets of corresponding side lengths. I now need to determine which is triangle 1. So I'm going to call this triangle 1 and this triangle 2. And I'm going to write some ratios for those corresponding side lengths. I'm going to start with the purple side length here. So I have 30 and 12. So remember, I write my ratios as triangle 1 over triangle 2. So I have 30 over 12 for my first ratio. I then look next at the next ones in red, and I see that I have 16 over y. And then for green, I don't have any letters, so I can't use or create any sort of ratios from those. Now remember, I need these two ratios, whatever they are, in their simplest form, to be equivalent when they are simplified all the way down. So I'm going to take those two ratios, set them equal, and that will help me to solve for this missing y value. So I cross multiply here. I end up with 30y is equal to 12 times 16. 12 times 16 is 192. Divide both sides by 30. And I find y is equal to 6.4. That's what this y value here is equal to. Now, if you want to check your answers, you are more than welcome to. I'm going to do a little check here. If I look back at these original ratios here, 30 divided by 12, that first ratio is about 2.5. And then if I look at my second ratio, that would become 16 over y, which is 6.4. Divide those out, and I also get 2.5. So they are the same. Basically, that's telling us that this big triangle here is about 2.5 times bigger than this small one here. So now let's make this a little bit more difficult by finding two missing values in the same set of triangles. So let's start here by color coding our triangles. So we have A and B pairing up with E and F. We then have B and C pairing up with F and G. And then lastly, we have A and C down here pairing up with E and G. So we can now clearly see all of our corresponding side lengths. Now what I'm going to do first is I'm going to write three ratios down since I have three pairs of values, and then I'm going to see which pairs will maybe help me find x and y. So if I start with that first ratio, I have 8 and y. So remember, I'm doing triangle 1 over triangle 2. So this is triangle 1, this is triangle 2. Then if I look at those purple side lengths, I have x over 12. And then if I look at my green side lengths, I have 10 over 14. So those are my three ratios that ultimately, when they're in simplest form, will have the same value. So now I need to basically figure out which variable I want to find first and which variable I want to find second. So I'm going to start off here and I'm going to find x first. That's just my personal preference. I'm just going to work on finding x. So essentially what I need to do is out of these three ratios, pick two of them to set equal, and then hope that I only have one variable in that pair so that I can find what x is actually equal to. So since I'm going to find x, I'm going to choose x over 12. And then I want to choose another ratio that doesn't contain a variable at all, which would be 10 over 14. So here I now have two ratios that I can set equal using a proportion to help me find that missing side length of x. So here, if I cross multiply here, I end up with 14x is equal to 10 times 12. So that's 14x is equal to 120. Divide both sides by 14, and I find that x is equal to about 8.57. So there's my first value for x. I now know that x here is about 8.57. Then if I move on, I'm going to look at a different pair of values now, and I'm going to make it my goal to find y. So I'm going to use this ratio here to help me find y. So I have 8 over y is equal to, let's again choose another ratio that has only numbers, no variables. I'm going to also set that one equal to 10 over 14. So here we cross multiply again, so 8 times 14 is equal to 10y. 8 times 14 is 112. Divide both sides by 10, and we find that y is equal to about 11.2. So there we have it. We've now found y and x for our missing triangles using our knowledge of ratios. So now let's make this just a little more difficult by taking our shapes and having a quadrilateral, which means we have 4 sides, and turning that shape around so those corresponding sides aren't as obvious. So now let's start the same way we have before. Let's color code our shape by using our similarity statements. So we have M and N pairs with A and B. So this similarity statement is super helpful because this shape is really turned around. We then have N and P pairing with B and C. P and L pairing with C and D. And then lastly we have, we'll make this one yellow, L and M pairing with A and D. So here we can now clearly see all of our similar sides that pair up together. So now let's do quadrilateral 1 over quadrilateral 2, and let's create ratios out of these side lengths so we can use them to find all of the missing values. So I'm going to start with the purple side first. So we have 4 over 10. Then I'm going to look at the blue side. So I have y over 14. That's a y, not a 4. Sorry, my bad handwriting. Then look at the yellow side of w over 18. And then I look at the red side of 6 over x. So I've got 4 ratios here, and I'm going to use these 4 ratios to help me find my 4 missing variable values. So let's start by deciding which variable we want to find first, and I'm going to start with y. So I'm going to start with this y here. So we have y over 14 is equal to, and remember I'm looking for another ratio that just has numbers, no variables, so that I can actually find what y is equal to. And that seems to be this winner right here of 4 over 10. So I set y over 14 equal to 4 over 10 because those are 2 ratios that need to be equivalent. I then cross multiply, so I end up with y times 10 is equal to 14 times 4, which 14 times 4 is 56. I then divide both sides by 10, and I end up finding that y is equal to about 5.6. So I already found y. That was pretty quick. Now I'm going to focus on w next, so switching colors here. We're going to find w. So we need the ratio that contains w, which is right here, so w over 18. And then again, I'm going to use this all numbers ratio of 4 over 10. So again here we cross multiply. So I have 10w is equal to 18 times 4. 18 times 4 is equal to 72. Divide both sides by 10, and I end up with w is equal to 7.2. All right, and last but not least, we're going to actually find x. So now I'm going to use my ratio with x. So 6 over x is equal to 4 over 10. Then I cross multiply here. So I end up with 6 times 10 is equal to 4x. So I get 60 is equal to 4x. Divide both sides by 4. And I find x is equal to 15. So then if I go back to my picture, this is telling me x is equal to 15, y is equal to 5.6, and w is equal to 7.2. And given my picture, all of those values seem to in fact make sense. So we're now going to take this one more step further. So if you look here, we have a similarity statement, and what's tricky about this one is we actually have two triangles in one picture. So what I like to do is take this picture and split it into two different triangles so I can actually see what my two triangles are. So if I follow my similarity statement, it's A, C, and B. That's my big triangle. So I'm going to draw that out over here instead of having it all in one picture. So I have A, C, and B, and then I'm going to label those different side lengths. Now, side length AB, I can clearly see here is 10. But then, to me, what's very tricky is I notice that this side length here is y and 48. Now, what's implied here is that those two side lengths added together, if you think about length, if y was 10 and it was 48, those would add together to be 58. So what's really happening on that shared side length with the two values is you actually have an addition going on. So this is y plus 48. That whole side length is y plus 48. So we're going to put that little plus sign in there to account for y plus 48 for the whole side. And then we're going to do the same thing down here. This is really x plus 36. So here we have our big triangle of ACB. It has a side length of AB that is 10, a side length of AC, which is y plus 48, and a side length of BC, which is x plus 36. So here I have my first triangle drawn out of this picture. So there's triangle number 1. Now I also want to draw triangle number 2, which is DCE. So there's my little triangle. So again, I'm going to pop this little triangle out. And here I have DCE with side lengths of 8, 48, and 36. So I can see those side lengths in there. So now I'm happy because I can actually see my two different triangles and try to identify those corresponding sides. So now I'm going to move on and actually identify the corresponding sides. We have A and C. Those are corresponding with D and C. Then I have C and B corresponding with C and E. And then lastly, I have A and B corresponding with D and E. So I can now see all of my corresponding side lengths. So these take a little bit of time to set up. You want to draw the two triangles separately so you can clearly see them. And then from there, you want to identify all of those corresponding side lengths. So now that we have our corresponding side lengths identified, let's create all of our ratios. So I'm going to have triangle 1 is this top one, triangle 2 is this bottom one. So I'm going to start with my orange sides here. Go back to my colors. So I have 10 over 8 as my first ratio. I then have as my second ratio, if I look at the blue side lengths, y plus 48 in the first triangle over 48. And then if I look at my green side lengths, I have x plus 36 over 36. So here I can see I have 3 different ratios that will help me find all of my missing side lengths. So now from here, what I'm going to do is I'm going to take 2 of these and I'm going to decide which variable I'm going to find first. So let's start with finding y. Let's start there. So I'm going to choose a ratio that contains y, which is right here. So I have y plus 48 over 48. And then I want one with two numbers, so I'm going to choose 10 over 8 and set them equal. Now, hopefully what you're noticing is that this one looks a little bit different, but we have all of the knowledge that we need to solve it. Since this y plus 48 has two things in its numerator, I'm going to surround that with parentheses, because I know that will ensure that I don't make a mistake when I cross multiply. So I'm going to surround it by parentheses, so that's really 8 times y plus 48 is equal to 48 times 10. So I'll distribute here, so I have 8 times y and 8 times 48. 8 times 48 is 384. That's equal to 480. I then need to subtract 384 from each side. So I end up with, I'm going to jump down here, 8y is equal to 96. Divide both sides by 8, and I find that y is equal to 12. Which, if I look at my picture, seems to make sense. If this was about 12, then this whole side length here becomes 60. And that looks like it could be about right. So now I'm going to apply the same type of thinking to help me find x. So I'm going to find x here. So here I'm going to use x plus 36 over 36, and I'm going to set it equal to the ratio with two numbers, which is 10 over 8. We then notice that we want to put parentheses around that x plus 36 before we cross multiply here. So I have 8 times in parentheses x plus 36 is equal to 10 times 36. So we distribute here, and that becomes 8x plus 288. That's a 2. And that's equal to 360. We then subtract 288 from each side. I'm going to bump it up here. So we have 8x is equal to 72. Divide both sides by 8, and we find x is equal to 9, which again, if we kind of go back to our picture here, that would mean that this side length here is about 9, which makes sense. And then this side length here, this x plus 36 would actually be 45. So that to me all makes sense. So notice how we can take this concept that's very small and we can actually grow it to solve triangles that are much more complex and find all of their missing side lengths.